Good afternoon everyone. I am Rupavani from MS Ramaya Vidyaniketan. Today I would like to give a demo on STEM DLD grade 5 mathematics. So today we gathered here to discuss about STEM education. Actually, what is a STEM education? STEM education means students are actively participated in experiments and projects through exploration that helps them to understand better concepts. So now let's get into this topic of benefits of STEM education. What is the benefits of STEM education? According to NEP 2020, these 5 C's are very important to enhance world solving problem ability and then greater understanding of today's world. What are these 5 C's? Critical thinking, confidence, curiosity, collaboration, creativity and final innovation. So now let's get into my topic. By seeing these images, do you find any idea? Any guesses? Audience, any guesses? Okay. It look like a art. It look like a natural structures, and it look like artificial, and then it look like architectural designs. Okay. My topic is today discovering symmetry. Now, what is the learning objective of discovering symmetry? To build conceptual clarity of symmetry, that is line of symmetry, reflective, rotational, through patterns and more exploration. Understand what symmetry is and be able to define the in their own words. Distinguish between what is a symmetry, that is two type of symmetry, line of a symmetry and rotational symmetry. Identify and recognize symmetrical objects that they everyday in their life to foster STEM skills. Now what is a symmetry? See, I want to show you with the example a symmetry, a shape or object which is divided into two identical halves, that is called as a symmetry. For example, see here, this is the watermelon in my hand. A object or a shape which is divided into two equal halves, that is called as symmetry. See here, you can find some patterns in the symmetry. You can find the patterns in the object. So that is called as a symmetry. Now I want to ask you that, see, is this is the flower. Is this a symmetrical image? Can you tell me, is this a symmetrical image? Yes. Yes. How means a image or a shape which it completely covers into other halves. Which completely cover into other halves, that is called as a symmetry. Then this is also perfect example of symmetrical image. Now I want to show you one more example of a non-symmetrical image. See, this is the bird. This is the bird. If I fold this bird in, we can equally cover it? No. So this is called a non-symmetrical image. Now, what is the line of a symmetry? Line of a symmetry, for that, an imaginary line that can be drawn, that object can be divided into two equal halves, that is called a line of a symmetry. For example, I want to show you, take one sheet of paper and then fold it in the middle. Fold it in the middle, exactly half, and then this is the white marker ink that I want to take 2 drops of ink. Just 2 drops of ink enough. And then fold it gently and press the ink See, now you can find one cement, one beautiful pattern. Here you can find one beautiful pattern. So this is called a line of a cement. An imaginary line that can be drawn for an image or a shape, that is called as a, that is divided into two equal halves, that is called a line of a symmetry. Now, what is the rotational symmetry? Rotational symmetry is a special kind of symmetry. When an object can be turned, it still look like a same. When an object can be turned, but still it look like a same. For example, pinwheel we can call it as a windmill also. See, this is the perfect example of rotational symmetry. Students usually ask so many questions about that. Ma'am, if an image turns also, how does it look like a same? How can we identify that if the picture is rotated, and then how does it look like a same? Then I showed them, put a one dot here and then you turn the image however you want. Then you can find the what is the turn, the image has been turned. So I want to show you here. So this is the original image of the picture, and then I am turning. This is 1/4 turn, means quarter turn. See, does it look same? Yes, very good. And then I would like to turn half turn, that is 1/2. Does it look same? Yes, very good. Then I want to turn 3/4. So does it look same? Yes, very good. Now I want to show you 360 degrees, that is complete the figure. So it look like a original image only. So this is called as rotational symmetry. This is a perfect example of rotational symmetry. I want to show you one example here. So see here, the windmill is rotating. So this is the perfect example of rotational symmetry. And we have seen these nowadays. We have seen these in movies also. In bank opening locker system, and also they will use a rotational symmetry only to rotate the locker, and then it can be opened. Now let's next one. Description of the practice. Students participated in a series of hands-on activities. They used paper, ink and thread. So by using these ink and thread, they have done one beautiful reflective image that I would like to show you. That is called as reflective mirror image. See here, this is the perfect example of reflective image. What is the reflective image? When I place a mirror here, the exact image can be shown in the mirror. So that is called as reflective image. So without mirror also, now we are seeing that this one is the perfect example of same thing that is copied but in the reverse way. So that is called as reflective image. Next, does it look same activity? I have done this one. Here I have already shown you. Does it look same, this kind of activity? I have done. They have used normal paper and ink materials. And then next, methodology. Pedagogical approach, experimental and inquiry based learning, role of students, active discoverers and documenters of symmetry, role of a teacher here, facilitator, guider and observer, used task, grasped the concept. Curriculum integration aligned with symmetry and patterns. Here see evidence based impact. See here my child, class 5 children has done these type of activities, And then students are using mathematical vocabulary very confidently, that is axis of symmetry and then rotational pattern. Reflections included like now I can find the symmetry in butterflies, tiles and then even in the dance. I would like to show you this one. One of my child has done with origami paper used, he has done butterfly very neatly, and then see he can find some patterns in the butterfly also. And then next one, increase in participation, especially hesitant learners. Hesitant learners, I would like to give a chance for them, so that's why they can come forward and then they can learn the things. Now mirror magic has been blending with math with art and nature. So our principal always suggests that, encourages us blend with other subject like blend math with science, math with English, math with social, so that children can expose more. So and then we have done some art and integration program also, that is second primary level, secondary level and final level, these and all we have done. So that's why we are able to do these type of activities. Now this is last year FLN activity. Now I have used symmetry and patterns so that child can learn in musical way also. So child can learn in musical way also. They can learn to identify musical patterns. These are the examples of symmetrical patterns. Now novelty and relevance. Combined math and art, cognitive and integrated with low cost materials, real world connections for nature, architecture and then daily patterns, everyday life and technology and functional designs. Many everyday objects like cars, tools, incorporate symmetry for stability and effectively for ease of use. Inclusivity and equity. Activities accessible to all learners and then varied motor learning abilities, pair and group work and peer support for voice for all, balanced gender participation, actively identify and misconception about symmetry. Earlier they have some misconceptions, now it is clarified that, but so many children still they have, so many children they have that they can't visualize the image properly when it comes to 1 by 2, 1 by 4, 10 like that. So we need to give more practice for them and then we need to give a chance to overcome their fear and then they can come and tell what they don't know. And misconceptions and all cleared. After that, scalability and replicability. Activities can be implemented in any classroom with minimal resource. Step-by-step guided activity they created for the teachers. Photographs and worksheets, generalizing templates and then replications. See here, I have done so many rangoli patterns and designs so that the child can know, and this is one of the best example of rotational symmetry also. So hand and eye coordination also it can be improved. That day you won't believe that my math classroom is completely converted into like a art and craft activity. So my children has done extremely very well, and then budget under 50 to 70 rupees for full, mostly reusable. See these things I have collected by because we can reuse these things. These are the best they have done. So I can use for board decorations whenever the festivals is there like Sankranti, these and all. I can use these things as a board decoration also. So that's why I collected from my children. Environmental friendly like organic paper and then natural materials, leaves and things. Activities integrated into regular math periods only, and then learnings and reflections. Students are more engaged when concepts are clear to connected to their real world. Initial confusions between pattern and symmetry was resolved. Now hands-on play activity. By engaging these activities, students develop a concrete understanding, reflection symmetry and its applications. Now further impressions, digital tools like animations. I want to create some simple animations so that they can create more. And then GeoGebra has been used for that. Simple animations will be there. They can see so many what is the line of symmetry and then rotational symmetry by enhance their visualization. They can enhance their visualization so that they can learn more. Now final conclusion, this practice helped learners see symmetry not just a math concept but a way of seeing the world and deeper understanding through a multisensory approach. Now it showcases the power of hands-on STEM learning. Thank you.